Okay, so today's lesson is all about equivalent expressions. So we're going to be doing a lot of distribution, combining like terms, just to show whether or not something is equivalent to another expression, and then we're going to justify why it's equivalent or not equivalent. And we're just going to start really basic by going over your opener. So if we look at expression 1 and 2 in question 1, we have 4 plus negative 2, okay, and we have negative 4 minus 2. Okay, and when we think about whether or not those two are equivalent, we could calculate, but really we could just use the definition of subtraction. So these are actually equivalent, and the reason that they are equivalent is subtraction is the same as adding the opposite. Okay, and that's a good enough justification for that. Okay, the second one, negative 3 minus negative 7 and negative 3 plus negative 7. And when we look at that, we can kind of use the same justification below, that subtraction is the same as adding the opposite. So these actually are not equivalent. And we could use the same definition, or I'm actually just going to kind of simplify what the first one is. So negative 3 minus negative 7 is actually equivalent to negative 3 plus 7. So remember, subtraction is the same as adding the opposite. So if we are subtracting a negative 7, it's the same as adding a positive 7. Okay, and then our last one that we're going to look at from your opener is 3 times the quantity x plus 2 and 3x plus 6. And hopefully you recognize that these are equivalent. And reason being, if we distribute that 3, that is equivalent to 3x plus 6. Okay, so we're going to go through a few more examples, but with more variables than numbers. Okay, so we're going to go back to that question that we worked with on Friday in classwork, where we had the tables that were being pushed together. The rule is the same as the rule that we did on Friday. Okay, even though the shapes are hexagonal in this one, it's still, you fit 2 on each end, and then 2 at the top, 2 at the bottom on each table. So the rule is the same as that classwork assignment, and I'm just going to write that up here. So the rule was P equals 4n plus 2. And that was from our classwork on Friday, so you don't need to memorize that. You don't need to go back and look for it. I'm just copying it down right here. And we are going to go through A, B, C, and D just to rewrite them to see if they actually are equivalent to that rule. Okay, we're going to be doing a lot of combining like terms, distribution, and so on. So if we look at this first one, P equals 1 plus 2n plus 1. We also want to remember our rules, our orders of operation. So we're going to multiply first, okay, and that becomes 1 plus 4n plus 1. Okay, and then we have the 1 and the 1 that are like terms that we can combine. So 4n plus 2. Okay, and if we look back up to our rule, that is equivalent. So I'm just going to put yes. Okay. Let's take a look at B. So for B, again, order of operations, we're going to do the multiplication first. This time we have to distribute. So I have 4n minus 8 because I'm distributing that 4. And then I still have the plus 5 on the end. Okay, so what can I combine? I can combine 5, negative 8, and 5. Okay, so if I do that, I still have my 4n, and then I have 5 minus 8 is -3, add 5 is 2, so 4n plus 2. So yes, that one is also equivalent. Let's look at letter C, which is Chris's rule that he wrote. Okay, we have 4n, 1 and 1. There's no multiplication to be done, so we're just going to go straight to combining like terms. 1 and 1 is 2. Oops, excuse me. 1 and 1 is 2. So that rule also works, because we ended up with 4n plus 2. All right, last one. We have some distribution, so I'm going to go ahead and do that. So I have 6n, -2n, because -2 times n is -2n, and then -2 times -1 is a +2. Negative times a negative is a positive. And now what can we combine? We can combine the two n's. So 6n take away 2n is 4n, and 4n plus 2 is the same rule, so it's equivalent. So all four of these are equivalent to the rule that you wrote in class on Friday. We're going to check two more. We're going to check Kathy and Troy. So let's start with Kathy. Okay, we're going to start with our rules of operation. Order of operation, -1 times n is -1n, and -1 times -1 is a +1. Okay, looking at like terms, 6n and -n I can combine, and that gives me a 5n plus 1, so that is not equivalent. Right, we're going to look at Troy. And looking at Troy, we are just going to go straight to combining like terms because there's no distribution. I have 6n take away 2n. And when I do that, that gives me 4n plus 2. That is equivalent. So the only expression that was not equivalent was Kathy's. All right, we've got 3 more examples, and really these last 3 examples, this is what your homework is going to look like. You're going to have a table where you're going to justify whether these are equivalent or not. Okay, so the first one that we're looking at, we are looking at 5x plus 3 and 5x plus 15. So remembering that we have to distribute that 5, and when we do distribute that 5, we get 5x plus 15. So yes, these are equivalent, and then we can show that 5x plus 3, if we distribute, is 5x plus 15. Okay, and that work right there, that's enough of a description, or justification rather. Okay, so next one, if we look at 6x minus 4 and 6 times x minus 4 in parentheses, you should be thinking, well, I would be distributing the 6. So if I distribute the 6 would also be times -4. So if I did that, 6 times x minus 4, that would give me 6x minus 24, which means that they are not equivalent. And again, showing that work is enough of a justification. Okay, and then we have 10x plus 3 and 3 plus 10x. Do we think that those are equivalent? Let's think about this for a second. If I add 2 plus 3, is that the same as adding 3 plus 2? It is. So these are equivalent, and we can say that they're equivalent because addition is what we call commutative. And what that means is order doesn't matter when adding. All right, all set. Good luck on homework. I'll see you guys tomorrow.